are, okay? We talk about the rate of change. And the key idea is that you got to know that for a linear function, the first difference is a constant. That is the key idea. That's important. Then for quadratics, the second difference is a constant. So make sure you know that. In addition, your first difference will help you determine if the function is increasing or decreasing. If the function is increasing, the first difference is going to be positive. If the first difference is negative, then that means your function is decreasing in that interval. Okay? We also talk about maximum and minimum. We call this global max because that's going to be the highest point of the entire function, the whole function. And what we notice is that if the function, changes from increasing to decreasing, you will get a global maximum. If your function changed from, in this case, notice the function decreased and then it's changed to increase, then you will get a minimum. So that's what we discussed. We're going to move on to the next set. So go to page 2 now. Okay? We're going to do this as one last practice. The key idea is the third cubic function is when the third difference is a constant. So I want to zoom in. That way you can see it. Okay? We're going to go into this one right here. Now, for cubic, if you take a look at your input value, it does say again, the input value increase in equal length interval. So you can see here, your x go up by 1 throughout. Yes? That's what it means by equal length throughout. Now, if this go up by 1 and then suddenly it's changed to go up by 2, then that's no longer equal length interval. Is that good? It has to be going up by the same number throughout the table. So they tell me the first difference is a constant. That means you're going to have the first difference, the second difference, and then the third difference. Did you guys see that? So we're going to have to write small so that we have enough space, okay? So this is our first difference. And again, keep in mind, we're going to take the negative 8 and then we minus the 27. So we're going to have to write that over here because I don't want to write here. So I have negative 8. Subtract negative 27. Yeah? So that means this should be a plus. Is that okay? So negative 8 plus 27, that's going to be 19. Is that good? So we're going to write 19 right here. How we doing? We okay? All right, let's find the difference for me, please. So you guys go ahead and you do that. Okay? Right here. Okay? So go ahead and take that. So again, in your mind, this is your calculation. Negative 1 minus a negative 8. Yeah? So that should be a plus. And then that should be the 7. Like that. So go ahead and do that for me, please. Let's finish it up. Shh. Josh Marr, shh. Here's your schedule. Get it? Yep. So if you take a look right here, stop, shh. I'm recording. Quiet down. So if you take a look at the first difference, you're going to see that the first difference is 19, 7, 1, 1, 7, and 19 again. Yes? Based on this, I know this is not linear because my first difference is not a constant. Yeah? And I also know because the first difference, which is my rate of change, the numbers here are all positive, this tells me my function is increasing. Is that good? Throughout the interval from -3 to 3. Are you guys good? So on that, I'm going to write this first. F of x is an increasing function because the rate of change, which is the first difference, we're going to write that, because ROC, which is the first difference, we're going to have to abbreviate because I don't think I'm making enough room for it. The first difference is positive. Okay? So the rate of change, we call that the first difference. In this case, they're all positive. So the function is increasing. Any questions on that? Can we move on? All right, so now if it's not linear, we have to check now if it's quadratic. Are we all right? So we're going to check the second difference. So now we're going to do this again. Okay? And I'm going to label this second difference. Make sure you have a third difference if you can squeeze that in, okay? So if I take 7 and I minus 19, so that's going to give me -12. You guys see that? So I'm going to write -12 here. And then 1 minus 7, that's -6. 1 minus 1, 1 minus this 1, that makes 0. 7 minus 1, that's going to be 6. And then 19 minus 7 is going to be 12. Since the second difference is not the same, is not a constant, this table is not quadratic. Did you guys see that? Now, we know what the answer is. We know the answer is cubic. But on the AP exam, they're not going to give you that. They're going to give you something like this. You guys see that? And they're going to say, hey, is this table represent linear, quadratic, or cubic? Do you guys see that? So this is something you have to check. Are we okay? Based on this, it's not quadratic. Are we all right? Okay. Now I'm going to look at the next one, which is the third difference. And this is going to be the last one. Okay? So if I take -6, so that's a -6, and I subtract the -12, so that's going to give me a +12, right? 2 negative make a positive. And I'm going to get a 6. So that's what I'm going to write right here. That's my third difference. Okay? If I subtract again, that's 0 minus a -6. So that should be a +6 again. So that would be 6. Okay? It's the negative that you have to be very careful. All right? Go slow on that one. And then 6 minus 0, we know that is 6. 12 minus 6, that's also 6. Because our third difference is a constant, we can now conclude that this table is cubic. Are we all right? Yes? Any questions on that? Okay. Now we're going to make a little sketch of this graph. Is that okay? Somehow I forgot to give you the little x and y axis, so you're going to have to draw that in for me. Okay? Let's do that here. So count 1, 2, 3, 1, 2, 3, the fourth line, kind of like that, and draw it down. Okay? And let's just do it this way, like that. Let's draw that in. So I know that at -3, I have to go to -27. I won't make that because my graph is not big enough. You guys see that? But I can do -8 if I go by 2. So I'm going to go, this is -2, -4, -6, and -8 is right here. So I'm going to say here's, I'll go by 1 for this one. It's going to look very weird, but it's fine. So there's -2. I have to go down to -8. That's what this tells me. Okay? At -1, I got to go down 1. So here's -1. 1 is halfway of 2. Okay, so it's like right there, right here. So that's this one. 0 is 0, so that should be okay for me. There you go. You guys see that? Yes? So now, if I were to connect these dots, and I'm going to graph just these first, I know that because my first difference is a constant, and it's no, it's not a constant, it's a positive number, my function is increasing. So if you connect from this leftmost point all the way up here, do you see that your function is increasing? Do you guys see that? That's what this is telling you. Is that all right? Yes? And now if I were to keep going, right? At 1 is 1, so here's 1. This is 2, 4, 6, 8. At 1, I go up 1, so that's halfway. At 2, I go up 8, so that's right here. So if I connect these dots, it's going to look like this. That's what my function looks like. And you can see my function is always increasing.
Is this calculus right here?
Shh. No. Any questions on this? Are we good? Now, what you are doing is you're analyzing the function. Is that good? In Math 3, you've learned this already, but there's no analyzing going on. Is that all right? And that's what you're doing now. Now, based on this, you can see that your function does not have a maximum nor a minimum because this thing is going to keep going down and up. Do you guys see that? So that's why it says here, the function does not have a relative max or a relative min, because if you look at your rate of change, do you guys see that it doesn't change sign? They always stay positive? Yes? If you have a max or a min, you need to see that there's a sign change, like from positive to negative or from negative to positive. Do you guys see that? So this is what we're going to write. F of x does not have a relative max nor a relative min because the rate of change, the ROC, yeah, which is the first difference, I write really close, sorry, because I'm running out of space, yeah, does not change signs. So take a look at your first difference. That's why it's important that you know the first difference. It will tell you the behavior of your original function. Okay? Now, we're going to go and talk about the second difference. The second difference is right here. You guys see that? Do you guys see that the second difference does change from negative to positive? Yeah? It does tell something about the graph. So if you take a look at the graph, do you guys see that, so it's from -3 all the way to 0. That's when the second difference is negative. You guys see that? So look at the interval from there, from -3 to 0, which is right there. Do you guys see that your function, while increasing, is concave down? It's open down. Do you guys see that? So the second difference will tell you if your function concave up or concave down. Is that good? Yes? So in this case, because the second difference is negative, this tells me from -3 to 0, that's where it stopped, the function will concave down. So we're going to write that. The rate of change, that means your second difference. Rate of change is the first difference. If you put another word rate in front of it, that's the second difference. Okay, so rate of change. The second difference is negative on the interval from -infinity. So we're going to write here. Here's -infinity all the way to 0 because this thing is going to keep going down and spread to the left. So that's from -infinity to 0. So the graph of f of x, concave down, okay, on this interval. So if the second difference is negative, the function concave down. All right? That's what you see here. The function increasing but concave down. Now take a look here. The function, while it's increasing, it's concave up. Do you guys see that? And if you're like, Ms. Tran, I don't see the concave up. Okay. When you look at concave down, this is what you see. That's concave down. Are we okay? But it doesn't have to concave down all the time. It can just concave down halfway. That is still considered concaving down. You guys see that? So most of the time when we look at analyzing the function, we sort of break it out two parts. This is concave down. This is also concave down. You guys good? You might only see half of it. You might not see the entire thing. Okay? Concave up means it look like this. But again, you can break it out as here's this part is concaving up, and then this part is also concaving up. You guys see that? What's the difference, Ms. Tran? The difference is that this is decreasing. The function is decreasing and concaving up, while here the function is increasing and concave up. Do you guys see that? Yes? So when we analyze, we have to know both of them. Because if you know both, you can graph the function. Is that good? Without making a t-table. So here, one more time, we're going to look at this piece, okay? So this is from 0 to infinity, because this thing is going to keep going up and spread to the right. You're going to see that the function is concaving up, because take a look here. The second derivative, or the second difference, is positive. Do you guys see that? So that's from where? From 0 to 3, or in this case, from 0 onward, so infinity. So we're going to write that. This is the language you're going to see. The rate of change, which is the second difference, is positive. Okay, positive right here. Right there. These are positive. On the interval from 0 to infinity. So the graph of f of x concaves up on this interval. Okay? At 0. Now, this is a new vocabulary now. Do you guys see that at 0, that's when the function changed from concave down to concave up? Do you guys see that? It's changed concavity. So we have a name for it because it's special. And that name is called point of inflection. That's when it's changed. Okay? So at 0, the function has a point of inflection, because the second difference changes from negative to positive at this value. Okay? Any questions on that? There's a lot of vocabularies, yes? So now I'm going to give you a little graphic organizer to help you with all of this, okay? And that's going to be on the next page. This is the page I asked you to change out. And we're going to practice on that. We should have enough time. All right, here we go. When we talk about the function means it's the graph. Is that good? The function is the graph. The function can be positive. Now, what does that mean, Ms. Tran? It means that your function, I'm going to give you a little sketch, okay? So please pay attention. If the function is positive, this is the y. Your function is your y, okay? Positive means your graph is up here. So I can say my graph is something like that. But it's up here, it's not down there. That's when the function is positive. Are we good? If the function is negative, that means your graph is down here, since the y value is the negative one. Negative y is down here. You guys see that? So if I say the function is negative, I'm telling you, hey, your graph is down here. It will never go up there. Does that make sense? So it's going to be like, I don't know, something like this. Yes? But the graph have to stay down here. Is that good? Now, can you have a mix, Ms. Tran? Can the function be like both positive or negative? Yes. Let me show you one so you can see it, okay? If I have something like this, then I can say from here, from like this piece, right? From here to here, the function is negative because this piece is in the negative region of y. Do you guys see that? And then from here to here, from this interval to this one, this piece, the y value is positive. Do you guys see that? If your graph have a mix, you gotta cut them up so that you can talk about each of those regions. Does that make sense? And we'll talk about that. But that's what it means. Now, if the function is like this, that means the function is increasing. So here, the function is increasing right there. Do you guys see that? The function is increasing right here. So increasing is from what piece to what piece is the function going up. The function can decrease, or the function can concave up, concave down. Concave up is this. This is concaving up. You guys see that? This piece from here to here. You guys see it? Yes? Then here to here, that's concave down. Everybody okay? Yes? Now, that's your function. What does it mean for your first difference, which is your rate of change? Well, if the function is increasing, that means your slope, which is your rate of change, is positive. You guys see that? If the function is decreasing, your first difference, which is your rate of change, which is your slope, is negative. Everybody okay? If the function's concave up, your rate of change is increasing. That means your first difference, the number is going to get bigger and bigger. Yeah, as x get bigger, your first difference is going to be bigger. If the function concaves down, your first difference is decreasing. That means if you look at the first difference, your first difference is going to get smaller and smaller in value. Okay, your first difference is the difference that we took. The second difference, that means, again, you take the second difference. If the second difference is positive, this tells you the first difference is increasing and your function concaves up. Is that good? So this gives you a summarize of everything we just talked about. Is that good? So we're going to put that into practice in this example. Okay? And again, if the second difference, which is the rate of change, is negative, that means your first difference is decreasing and your function concave down. So they line up. Are we okay? That's how you read this. Okay. Now, it says the tables give characteristic of the rate of change. So underline that, rate of change. That means your first difference. So when you read a problem, you got to make sure you can translate it for me. Okay? It gives you the rate of change of the function on different interval. Describe the function. So they ask you to describe the function itself. Okay? While they gave you the first difference. So if you take a look at the table, this tells you not y, this is the rate of change of y. So what they're giving you is this one right here. They're giving you this. Yep, they're giving you this. So you're going to have to look at this level. Okay? And then they ask you to describe the function. That means you have to look at these and then translate back up here. Does that make sense? So we're going to start with one of them. This is the interval from 1 to 2. They say the rate of change is positive. So if the rate of change is positive, that means your function is increasing. So we're going to write that. This tells me f of x is increasing. Right, small? Otherwise it's going to bleed into this one. And here it says the rate of change is positive and increasing. So now I need to know if the rate of change is increasing, what does that mean for my function? Well, here's the rate of change. If the rate of change is increasing, that means my function concaves up. Do you guys see that? So we're going to say f of x is increasing and concave up. That's how you translate that. How you doing? You okay? Now, bless you. What does it look like? Well, if the function is increasing and concave up, you have to look at these and see, well, which one match that. Concave up is here. Increasing is this piece. Do you guys see that? So I can say, hey, my graph had to look something like this. That's the piece that is increasing and concave up. Are we all right? Yes? So you're going to have to look at the table, okay? Now, rate of change, which is the first difference, is negative. So now you're going to have to look at your first difference. If the rate of change is negative, this tells me my function is decreasing. So we're going to write that. We're going to have to write it down here. F of x is decreasing and All right, now they say the rate of change is also increasing. So if the rate of change is increasing, that means my function concave up again. Do you guys see that? So we're going to write and concave up. And you're like, Ms. Ren, what does that look like? Well, look at the way that we have. We have concave up, so this is concave up. Yes? So which piece tells you that the function is decreasing? Well, it's this piece. The function is decreasing and concave up. Do you guys see that? So I'm drawing this one. So this is the piece. My graph should look like this. Decreasing, concave up. Are we okay? Question. All right, let's translate this one. If the rate of change is positive and decreasing, what's your function doing? F of x is what? Increasing, because the rate of change is positive. That means my function is going up, increasing. And if the rate of change is decreasing, what does that mean? That piece of the graph is going to concave down. So n concaves down. How are we doing? We okay? Okay, finish the last one for me. Finish the last one for me. Hopefully that is what you have. Are we okay? Now, Ms. Tran, how do I draw this? Well, take a look first. How does concave downs look? Oh, right here. This is concaving down. Yes? Well, which of these p's is the function increasing? Right here. The function is increasing and concave down. So your graph is going to look something like this. Okay? On this interval from 3 to 4. Are you okay? And then if the function is decreasing and concave down, well, that's this piece right here. So it's going to look like that. Any question? Are we all right? Yes? Now, we're not at the place where we're going to put them all together, but this is what you need to make sure you understand. Okay? All right, this is what I need you to do. Oh, you can't do that. So, I gave you the homework. It's this big package right here. You are going to be able to do number 1. So you're going to do that. Circle number 1. You do number 1 for me. Okay? And then circle number 3. You're going to do 3 and 5. 1, 3, 5. You're going to do that. Let's clean up. Get your stuff back. You're going to do your homework. 1, 3, 5. Okay? When I see you on Wednesday, we're going to go over those. But I want you to translate for me. The answer is there, circle it. 1, 3, 5. The whole country.